Hello guys, and today I would like to show you the MIC-1 processor simulator that me and some of my friends made for the college work. Uh, so if you want to test it, it is available at GitHub, okay, my GitHub account. It has a release here, but it's a little out of date because yesterday I made some modifications to it. Actually, today I made some modifications to it. Here are the contributors, okay? And let's go to the code. So, first, I would like to show you the assembler. It has an integrated assembler, so you can just paste assembly code into it, and it will assemble the code for you. So here's the assembler. Here, the first pass through the code searches for flags, which is a place where you can jump to. You can call these places by name, like this. Start, for instance, is a flag. End is a flag. Loop here is a flag. And we can jump to loop, we can jump to end. Okay. So, the second pass through the code here swaps the flags in this part of the code here when we are using the flags and variable names to numbers. Okay, and the last pass through the code here just assembles the line as a binary string here. So let's run it. I'm gonna show you the assembly process. So here we have the simulator. Here we can paste our assembly code. Here it will output the compiled code, the binary. Okay, we can type in the binary or paste it if you like. Here is the memory of the system, and here we can see the registers. Those are the speed controls for the simulation, and this is the start button. Okay, so let's take the code here, paste the code here. Okay, the program is now here. We can assemble the code, and very quickly you can see it assembled the code just fine. And now let me show you the simulation before I run the program. So it's in main. Control unit here. Okay. So if we take a look at it here, it is a thread that runs in parallel to the window and the other things. And here it is almost a one-to-one simulation to the real processor. So every single component that we have in the real processor, we have here as a class. So there are a few differences, just a few differences, like every single register is here. Okay. Every single component of the processor is here. Those components here that are part of the data path of the processor should run all the time, but this would make the simulation way too heavy for some systems. So they only activate in some parts here during the simulation. I won't waste a lot of time explaining to you the whole simulation code here, because this would be like too boring. I just want to show you that, well, we have a pretty accurate simulation. Yeah, here's the end of the simulation code. Let me just show you the ULA. Well, yeah, it's right, ULA. Here it does the operations in binary. Okay. Here is a sum. Here is the AND. Here is the identity. And here is the NOT. Okay, those are the operations that the EULA can perform in this processor. And yeah, every single register is just an array. We created the classes here to be easier to work with them. And if we take a look here at main memory, it is just a big matrix, like as you can see here. It is initialized with zeros. Okay, so let's get back to the simulation. Here I can apply a pause of 10 milliseconds between subcycles of the processor. I apply the pause. I apply the code to the main memory. Let's start the simulation. So the code is here. The variables are appearing here, as you can see. And this program here is used to calculate numbers from the Fibonacci sequence. So, and record them to the stack of the processor. You can see the stack here, like the values are appearing in the stack. I can, during the execution, control the speed, so we can see it is running faster now. Let me get it a little faster. Okay, this is the last number it calculates. So it reached the end of the program here, this line, which says AND jump to AND, so it gets stuck in this part here. Okay, so that's a simulator, guys. If you liked it, please leave it a comment. You can go in the GitHub page and use it for whatever you want. Well, that's it for today. Thank you all for watching.